All right. Thanks everyone for joining today. Some people are still logging in, but we're going to get started. Welcome again to today's webinar from Lattice Technology. Our topic today is how to create assembly work instructions from any CAD system. Our plan is to keep this to 30 minutes, and you'll be receiving a recording of the webinar. Please submit any questions you have in the GoToWebinar console. You should see that on your screen. We'll cover those at the end as time allows, but we will end promptly 30 minutes after. And if we aren't able to get to your question, we will respond to you offline. So please feel free to submit those questions as they come to mind. So today we're going to be talking about assembly work instructions and how they can be created from any CAD system. Doesn't matter what CAD system you have. And we are talking specifically about assembly work instructions, but keep in mind this same procedure that's going to be covered today can be used for any instructions that you want to create where your 3D model is central to what you're trying to describe. So it might be service instructions for internal use, for example, or it might be customer instructions. So it's any instructions where you want your 3D model to be part of that instruction set. So I'd like to introduce today's speaker, Mark Jablonski. Mark's a consultant for Lattice, and he's also co-authored the book 3D Manufacturing Evolution with the co-founder of Lattice Technology. And everybody will be receiving a PDF copy of that. So Mark, Mark, before I hand it over to you, I've got a polling question. So if people could please take a minute to respond to this. Wrong question. Hold on. That happened. Hold on. Okay. Here we go. Let's launch this poll. So, which best describes your role? Are you a product designer principally working to develop products? Are you on the manufacturing and production planning side where you're figuring out how to make the products that have been designed? Are you in QA, or maybe you're in service and you're doing planning for how you should be servicing your products? Or if you're other. So please, if you can just take a moment to respond to that. I'm going to give it just a few more seconds. Okay, 1, 2, 3. Let's close the poll. And now let's share the results. So a good amount of you, over a quarter, are in the design department. Manufacturing plan makes sense that you guys are joining today. And others, if you guys wouldn't mind, other people, if you wouldn't mind submitting into the questions just what is your role, that would be very, very helpful. And Mark, I'd like to now hand it over to you.
All right, thanks very much, Mark, and thanks everyone for your attention. Today we're going to talk about how to use any CAD data to produce work instructions using XVL.
First of all, why use XVL for work instruction? Well, XVL has several advantages over the traditional method of authoring work instructions using photos and text. As you may know, that can be a cumbersome and time-consuming process. But with lightweight XVL 3D data, you can author work instructions easily and systematically, and you can create both 2D and 3D work instructions from the same step-by-step process data. Also, traditionally, you can't start authoring the work instructions until there's a physical prototype to be photographed. But XVL is derived from the 3D design data, so work instructions can be generated as soon as the model is complete. There's no need to wait for a physical prototype. Also, traditionally, it's difficult to update work instructions when the design changes, and difficult to reuse work instructions for different models. But Lattice tools make it easy to update XVL-based work instructions when the design changes, and to reuse the same instructions for different models. So how do you create work instructions with XVL? Well, the first step is to convert the 3D design data into the lightweight XVL format. From there, you're going to create a process tree. As we will see, this enables you to easily create 3D animations and 2D illustrations, as well as to publish 2D and 3D documents, and then also easily update the model and the process data when the design changes. The first step is to create the process tree, which is a step-by-step list of tasks. These tasks contain detailed text instructions, parts lists, and additional attributes. You can use the process tree to create 3D animations or 2D illustrations. Once you've authored all of these, you can save them back in the XVL file. And you can use this XVL file with other Lattice tools to publish your 2D and 3D documents. These can be in Excel, HTML, or 3D PDF format. And viewing is free with the XVL 3D viewer. Finally, when there's a design change, you can use the Lattice tools to auto-update the XVL model and the process data. The first step is to create the process tree. When a file is converted to XVL, it contains the original engineering bill of materials. Lattice tools enable you to define your own bill of materials that could be more appropriate for manufacturing or service processes. Once you've created your mBOM or service BOM, you can use this information to build the process tree, which is a step-by-step list of tasks to perform the procedure. The process tree contains not only the parts required, but also additional attributes such as work time, detailed text instructions, and required parts and tools. The Lattice tools allow you to author this information manually or to import and export this data from other systems. Let's see how this works. Here we have a model of a bike engine in XVL Studio. We've just converted the 3D CAD data to XVL, so here we have the geometry and an assembly tree, or EBOM, but we don't have a manufacture tree, or mBOM. Let's go ahead and create one. We can do that by simply dragging and dropping parts from the assembly tree, or EBOM, to the mBOM, and we can do that in any order. Or, if we like, we can initialize the mBOM as a copy of the EBOM. And here we have the whole thing here. No matter how we create the mBOM, it's independent of the EBOM, so any changes we make to the mBOM won't affect the EBOM, and vice versa. For example, if we want to rearrange parts, we can do that without affecting the order of parts in the original EBOM. We can also add manufactured parts specifically to the mBOM to represent things like consumables during the assembly process. We can also add specific manufacturer assemblies to gather parts together into manufactured kits. And again, these changes to the mBOM won't affect the EBOM. After building the mBOM, let's go ahead and hide the EBOM since we won't be using it. Now let's go ahead and build the process tree. We'll start by adding a base process, and then we'll just drag and drop parts from the mBOM onto the process tree. We can do this in pretty much any order because we can easily check it later. All right, have we missed any parts? Sometimes it's hard to tell. So let's take a look and see. Okay, this tool tells us that we missed a couple of plugs here. Let's go ahead and grab those. And let's check it again. No items found. Okay, so we've now accounted for all the parts in our process tree. Now let's check the order of operation. Now to do this, it's probably easier to visualize if we turn on opaque selection. Let's start here with the bottom case and step through the process. Okay, it looks like the crankshaft's out of order here. So let's close that and move it in the tree. Okay, start again. Okay, that's much better. When the process tree is complete, it gives us a step-by-step list of instructions for assembling the bike engine. Studio also allows us to add additional information to each of these tasks. For example, we can assign a work time for each task, and Studio will automatically add up the work time for the entire process. We can also author comments and instructions. Studio even allows us to import information from other systems, as well as export our process information to other systems. After you've created your process tree, you can use it to create animations. Lattice tools make it easy to create step-by-step animations for processes. Simply move the parts and save the positions to create the animation path. You can even add images and text to the animation. And animated components can be highlighted during playback. Here we're defining an animation path by moving a part and saving points. We took the engine top off, going up and sideways, and now the animation follows that path. Here we've extracted the bolt, and the washers, and now the ring. You can also add images and notes to your animation. The process tree can also be used to create illustrations. Lattice makes it easy to create 2D illustrations from the 3D model. Simply move the parts to lay out the illustration. You can also easily add notes and images to the illustration. Within the process tree, you can create a main view and multiple auxiliary views for each step. Here are some examples of creating illustrations in Studio. You can see you can move parts, add notes, and even create cross sections for your illustration. And each process step can have a main view and multiple auxiliary views. After you've created your process tree.
Okay, let's go ahead and pause it right there.
Yeah.
Mark, do you have any additional polling questions?
Yeah, let's see if I can operate this one right. So if you could take a minute, let us know what CAD system you use. And if you don't know, so just select the other or you don't know, if it's not one on the list or you don't know what CAD system you use. And I'm going to let this go for just a couple more seconds. And the people at SOLIDWORKS are going to be glad to see this. So 38% using SOLIDWORKS. Okay, very good. And let's do one more, Mark, and then resume. So Mark just talked about creating these assembly work instructions, the mBOM, all that's tied together. So how do you currently create assembly work instructions? Are you using general purpose tools, Microsoft Word, Excel, PowerPoint, Adobe, or do you have, are you using tools from your CAD or PEM supplier, MES tools, or other? Okay. A lot of you are using general purpose tools. Give this just a couple seconds more. Looks like that's pretty much it. And let me share those results. So a lot of people, as we find, oftentimes are using just how do we create this documentation? We just use common tools, cut and paste, and build them out. So Mark, I'm going to hide this poll, and it should be back to you now. Here we go.
Okay, thanks, Mark. Let's continue now.
And then author 3D animations or 2D illustrations, you can save all this information in the XVL file. Then you can use this XVL file with Lattice tools to publish your 3D or 2D work instructions. Lattice tools can automatically publish work instructions using templates in several different formats, including HTML, Excel, and 3D PDF. Here's an example of 3D work instructions in HTML. All of the views are cross-linked to each other, so selecting in one highlights the part or the part information in the other views. Here's an example of 3D work instructions in Excel. Again, you can see an animated 3D view as well as parts information and process lists. As the animation plays, the different process steps highlight. And here is the same animation in 3D PDF. Again, there's cross-highlighting between the different views, the process list, the 3D view, and the parts list. Here are 2D work instructions published as an Excel document. It contains illustrations, parts lists, and other information. There is still a 3D model behind the scenes here, so you can pop out a 3D view and select in the view, and it will be cross-linked to the 2D document. And here is the same work instructions published as a 2D PDF file. Finally, when there's a design change, Lattice tools enable you to auto-update the model. You can convert the new version of the model to XBL and then use Lattice tools to automatically update that model to add the bills of materials and the process information you authored previously. Once that's in the new version, save the XBL file and then use the publishing tool to automatically update the work instructions for the new version. Here's revision 2 of the bike engine model. We've just converted this model from the original 3D CAD data, so it includes the engineering BOM, but no mBOM and no process tree. Now let's auto-update this model to bring forward the mBOM and process tree that we authored in the previous version of the bike engine. First, we specify the file containing the previous version. And then we have Studio do a part-by-part comparison of the previous version and the current version. The results are shown here. As you can see, most of the parts are the same. We can scroll through all of this, or we can filter this list to only show parts that have changed. In this case, only the cylinder head seems to have changed, and specifically what's changed are its geometry and its properties. And you can see one of the different properties right here highlighted in red. Let's take a look at the geometry though and see what's different. We can do a visual shape comparison of the model here, and it'll show differences in red and green, whereas similar surfaces that haven't changed are shown in yellow. Once we're satisfied with the match, we can go ahead and complete the auto update. And here we have the second version of the model with the mBOM and the process tree that we've authored previously. Let's just go ahead and check the animation and make sure it's still working. Yep, this looks like the process animation we created earlier. So you can see now with just a few clicks, we're able to auto-update the new version of the model with all of the work that we did previously. That eliminates the need to do rework whenever there's a design change.
Okay, Mark, that's basically a summary of what we've shown here today, which is the ability to create work instructions from any CAD data using XBL. Now back to you.
Perfect. Any CAD data, doesn't matter. And we've got a question coming up about that. But first, let me do one more poll. This will be the last poll, you guys. So Mark talked about the creation of assembly work instructions and then deploying them. So in your current environment, how are you deploying these work instructions that you create? So we saw most people using general purpose tools, and how are you getting them out there to your shop floor? And the 2D here specifically, PDF is an example, and then specifically if you're doing 3D PDF is the third choice, and then other electronic, 3D electronic if you're not using 3D PDF. Let me give it just another second here. We'll close the poll, share the results. So some paper, that is very surprising to me. Thanks for sharing that. And then the 2D PDF isn't a surprise. 3D PDF is a format that we support, and a lot of people don't even know the standard Adobe Reader that you have on your machine supports these 3D PDF documents. So we actually have samples on the website you can download, and you can see a 3D PDF in action with what you have installed. Okay, so we're going to wrap up here. We've got one question, Mark, so far. I'll check back there in a second. So if you have any questions, throw them in there as we're wrapping up here towards the bottom of the hour. But question for you, Mark.
Sure.
One of the people asked about file size. So they have extremely large CAD models in the gigabytes. What's up with XVL with this?
Okay, that's a good point. We haven't talked about that. One of the things that makes XVL so powerful is that it compresses very large CAD data 100 times or more. So a gigabyte CAD file will be down in the megabytes in XVL. And typically that makes it small enough to be able to use on even lightweight laptops. And so you can use your original CAD data, your original design data with all of the parts right there on your screen. So when you're building the mBOM, when you're building the process tree, you have all of the geometry at your disposal. Other systems that can't handle that large data have to break the model up into smaller pieces, or only have assembly instructions for certain parts of it at a time. So by compressing the data down 100 times or more, XVL gives you the ability to work with much larger models when making your work instructions.
Great, thanks. All right, a few questions here, so let's work through these. Can you create different configurations that show similar but different assemblies? So imagine these are more like options that might be available in an assembly.
That's right. The answer is yes, you can do that. We have first-class support for what we call variations, which are different configurations or different trim lines in the auto industry. So that you can have the same instructions applied to different geometry or different specific parts based on the configuration that you've selected. So we do have full support for different configurations.
Great. Question about files supported. So CAD types that we can import. So the question is there added cost to open JT files?
There's no added cost to open JT files. We have converters for all of the major CAD formats and all of the interchange formats. And so you would specifically convert that format to XVL at the same cost as any other format that we have. So the answer is no extra cost.
No extra for JT. You just buy the converter option and you convert any major CAD system.
That's right.
Question about wire schematics. So the question is, how about wire schematics and wire assembly? So I guess this is getting into the electrical side, and so maybe just say a quick word about the wiring and cabling that we have with Lattice.
So we do have support for wiring and cabling, and that varies by CAD system. So in that case, what we would do is we would work with the customer to evaluate the conversion and make sure that we can convert over their specific wire types in their systems. There's also the ability sometimes to convert the wire to just a plain geometry, which of course can then be directly converted to XVL as well. So that's something we generally support, but it's more of on a case-by-case basis where we've worked with the customer to evaluate it.
And there is, with the electrical package, full routing in 3D space for cables and wires, and has a lot of functions to support that. But it's all tied to your model in 3D space.
That's correct.
Okay.
Yeah.
Switching gears a little bit, talking about ERP integration. So regarding the work times for each step, can this be tied to the routing times in a standard ERP system? So I guess actually they're probably recording work times in their ERP system and then pulling that data. They're asking, can that data be pulled in?
Yeah, that data could be imported into the system and then applied to our task, our process tree, so that each task would get the time that basically was reported by the ERP system and exported into our information. So the answer is, it's not a live link. You wouldn't be able to, like, for example, update that directly and have that update the process tree, but you could export that information and then have that reported on the work instructions that you've authored in XVL.
Very good. Here's another question. Well, actually, I haven't really talked about this, but the question is, does the software take input from the operator? Meaning, could the electronic instruction wait on a step before it receives a signal to input? So I'm assuming here we're talking about manual input, like have you applied the adhesive or something?
So in terms of the playback of the instructions, you can put in breaks and pauses that require user input. So for example, you could, if you're showing a sequence, you can have that sequence pause at the end and require the user to select something to move on to the next step. So in that sense of user input, the answer is yes. Yeah, but we could again talk to them specifically about that.
Yep. Question about manufacturing bill of materials. So what if the original BOM is not correct? Oh, does that ever happen, really? So what if the original BOM is not correct? Can the BOM be edited when you're creating the work instruction?
So the answer is yes, you can. If you have the authority to edit the bill of materials, then you can do that in Studio. You can then again update that information back to the original source by exporting that information as well. So that would be again, it's possible. It's again a case-by-case basis. Yeah,
and one of the strengths with Lattice is that you can, as Mark talked about, you can create multiple views of that same bill of materials. So not only can you edit it to add, correct, but then you could have a view of, oh, I need to view this by parts I'm going to procure versus parts I'm going to manufacture, or the sequence, whatever. You can have multiple views into that same bill of materials. Okay, we're going to take one last question here. Why don't we talk? Let's see. This will be the last question, and then any of these we didn't get to, we'll respond back to you. Do we support GD&T and FTNA on 3D parts?
The answer is yes. We can read in GD&T and FTNA when that information is available in the original CAD system. When we convert it to XVL, the GD&T and the FTNA can be converted over as notes or as text. It depends on the specific system and the specific GD&T elements in the original system. So yeah, that does appear in the XVL version of the model.
Great. All right. Well, with that, we're going to wrap up. Thank you, everybody, for joining. You'll receive a link to the recording and a PDF copy, a 2D PDF copy of 3D Manufacturing Evolution that Mark co-authored with the founder of Lattice Technology. And we'll be getting that out to you probably on Monday. So In the meantime, also, if anybody's interested in looking to the next level of detail, send us an email, and we'll work with you on that, do a demo, whatever's appropriate. Again, thanks for your time today, and thanks for joining us, and have a great weekend.